Hello everyone. Today we are going to discuss about types of mirrors and laws of reflection. We have two types of mirrors. First one, plane mirror. Number two are spherical mirrors. Spherical mirrors are again classified into two categories. One is convex mirror. Number two is concave mirror. Convex mirror, they are also called diverging mirrors. And concave mirrors are also called converging mirrors. Plane mirror is straight, it does not have any curvature, and plane mirror is nothing but a piece of glass, but it is painted with red lead oxide paint, and that painted portion is shown by these lines. So this part is basically the painted part, and painted part does not help in reflection. So it is also called non-reflecting surface. So the reflection does not take place from here. So this part of the mirror, it behaves as the reflecting surface, and when the light falls on it, it bounces back. So this part is the reflecting surface, or the non-painted. You can also say that this is a non-painted part or the reflecting part. Okay. Now, if you want to, categorize spherical mirrors are curved mirrors, or they are also called curved mirrors. And how do we actually make it? We take a glass sphere. Suppose this is a glass sphere, and that is hollow from inside. Now we cut this. This is a glass sphere, a thin glass sphere which is hollow from inside. Now we actually cut it into two parts. Now this part and the another one is over here. So these are the two parts of the glass sphere which we have cut into, and now it depends upon us whether you want to make this or this. So if you paint it, say for example inside with red lead oxide, then this part will become the reflecting surface, this one, and this becomes the reflecting surface. And if I paint it outside like this, then the reflecting surface is inside. This mirror is convex mirror, and this mirror is concave mirror. Okay, so convex are diverging mirrors and concave are converging mirrors. We will understand about them in the next part of the video. So mirrors are broadly classified into two categories, and the second one, that are the curved mirrors, they are also divided into two parts, categorized into two parts, convex and concave. Here is a brief understanding of all of them. Okay, now for example, you have a mirror, let's say a plane mirror, and laws of reflection can be very well understood with the help of plane mirrors. Okay, these laws of reflection is true for all kind of reflection, whether the reflection is taking place from plane mirror or spherical mirror. If there is a reflection, that means reflection laws will be definitely followed. The first law of reflection states that the angle of incidence is equal to the angle of reflection. That means here we have a plane mirror in front of us. Now let us say that there is a source of light like this, and from here there is a ray of light that is going to fall on the mirror. So let's say this is the ray of light. This ray of light is called incident ray, as it is falling towards the mirror. This is called point of incidence. From point of incidence, you are supposed to make a perpendicular line. This perpendicular line should be perpendicular to the mirror. This line is called normal. This is called incident ray, incident ray always falls towards the mirror, and the angle between the incident ray and normal is called angle of incidence. Now we have to measure this angle. At the same angle over here, the reflected ray goes. So the reflected ray is this, and the reflected ray bounces back from the plane mirror after reflection, and the angle between the normal and the reflected ray is called angle of reflection. Now the angle of incidence and the angle of reflection are both the same always, and we will try to understand why it is so, but not in much depth, as we are restricting our lectures only for grade 7 and 8 students, and the proof for this, that why angle I and angle R are equal, is actually derived from Huygens principle. This is actually a part of a subject called wave optics. So this comes in grade 12, and from there you can actually prove that angle of incidence and angle of reflection are the same. Okay, we may interpret in this way also, that there is a plane mirror in front of us and this is the object. Suppose there is a light which needs to go from point A to point B through the reflection taking place over here. So that means a ray of light has to pass through A, it has to strike the mirror, and it has to reach B. It cannot directly go like this. So there are many multiple ways in which the ray of light can go. Ray can come through A like this, and after bouncing it may go like this. Over here, if you draw the normal, you will see that the angle of incidence and angle of reflection are not equal, and you will see that the light, when it travels from point A to mirror and then to point B, takes certain amount of time, say for example T1. Now take another path. There are multiple paths that are possible for the same situation. So again, this is point A. The light has to hit the mirror from here. This is angle of incidence. If this angle of incidence and reflection become equal, and if it reaches like this, the time taken by the light to go from A to mirror to B is T2. Then if these two angles are equal, then this time taken by the light to reach from A to mirror to B will always be minimum. This is called Fermat's principle. In Fermat's principle, we say that light reaches from A to B via shortest path, and it takes very less amount of time. That can be only possible if angle I and R are equal. Had it been the case, if I and R are not equal, then the time taken by the light to reach from A to B is not the minimum, and light travels from A point to B point in such a way that it takes minimum time, and minimum time is only possible if angle I and R are equal. Okay, second says that the second law of reflection states that the incident ray, reflected ray and normal, they all lie in same plane. How do we understand this actually? So for that you need to be understanding about the planes. So let us assume this white sheet of paper on which I am explaining is a mirror, and here somewhere on the top I have a source of light, say for example my finger, and from here the ray hits the mirror, I mean the white sheet of paper, and it forms V shape like this, and it goes like this. And if you look very carefully, that this is the incident ray. From here if I draw the normal, then the normal would be like this, and the reflected ray would be like this. Incident ray, normal, reflected ray, they all lie in this perpendicular plane. So that means all of them, they lie in same plane.